Hello everyone, I am going to explain about a Markov chain. This Markov word is derived from the scientist, that is a Professor Andrei Markov. Definition of a Markov chain. A Markov chain is a mathematical process that transitions from one state to another within a finite number of possible states. If the time parameter is a discrete t1, t2, t3 up to tn, it is called as a discrete time Markov chain, DTMC. If time parameter is a continuous, t is greater than or equal to 0, it is called a continuous time Markov chain, CTMC. Markov chain key features are a sequence of trials of an experiment is a Markov chain if first one, the outcome of each experiment is one of a set of discrete states. Second one, the outcome of an experiment depends only on the present state and not on any past states. Transition matrix contains all the conditional probabilities of the Markov chain. That is, Pij is equal to probability of a state n plus 1 is a Si, state n is a Sj. P is equal to P11, P12 so on up to P1r, where Pij is the conditional probability of being in a state Si at a step n plus 1 given that the process was in state Sj at a step n. Transition matrix features are, it is a square since all possible states must be used both as a rows and as a columns. All entries are between 0 and 1 because all entries present probabilities. The sum of the entries in any row must be 1 since the numbers in the row give the probability of changing from the state at the left to one of the states indicated across the top. Special cases of Markov chains. Regular Markov chains. A Markov chain is a regular Markov chain if some power of the transition matrix has only positive entries. That is, if we define the I and j entry of P to be P, then the Markov chain is a regular if there is some n such that P of n is greater than 0 for all values of I and j. Observing Markov chains. A state S of a Markov chain is called an observing state if once the Markov chain enters the state, it remains there forever. A Markov chain is also called as an observing chain if it has at least one observing state. For every state in the chain, the probability of reaching an observing state in a finite number of steps is non-zero. Examples are, first one is a regular. Since all entries in A square are a positive, matrix A is a regular and a not regular. These two examples, regular and a not regular. Irreducible Markov chain. A Markov chain is irreducible if all the states communicate with each other, that is, if there is only one communication class. I and j communicate if they are accessible from each other. This is written as I is equal to j. Some applications of Markov chains. First one, physics, chemistry, testing. Testing means Markov chain statistical test producing more efficient test samples as replacement for exhaustive testing. And then speech recognition, information sciences. Queuing theory. Markov chains are the basis for the analytical treatment of queues. Example of these, optimizing telecommunications performance. Internet applications. The page rank of a web page as used by Google is defined by Markov chain. States are pages and the transitions which are all equally probably are the links between pages. Genetics. Markov test generation. Generate superficially real looking test given a sample document. Example is, in bioinformatics they can be used to simulate DNA sequences. Thank you.